I would also like to thank once again all the speakers of the conference for joining us to share their knowledge, their expertise with the audience. Our next speaker is Ivan Asilidis, the CEO of AIRI. Ivan grew up in a family of scientists, of mathematicians to be exact. He is the youngest doctor of sciences in his area of expertise. Everything related to AI is in his focus of attention, and he will talk about AGI and its applications in his presentation. Please welcome Ivan Asilidis, the CEO of AIRI, towards AGI, towards applied artificial intelligence. As I was preparing for this conference, I thought that I would like to talk about a lot of many things, my research, my team's research, but there is something that's even broader than that. I am the head of AIRI, and today Dmitry Chernyshevsky called it AIRI. Well, I call it AIRI. So the main mission of our institute, of Artificial Intelligence Research Institute, is to create universal AI that can solve real-world problems. It's a big mission. It's an ambitious mission. How do you approach it is a big question. In my presentation, I will try to highlight some of the brightest examples and the basic terms and definitions that will help you, I hope, clarify our approach to delivering on this goal. I hope this will be helpful because we have spent a lot of time thinking about this, doing our research. It seems that if you set the goals precisely, exactly, it makes your work a little easier. Because the history of Russia has been such that we had science, then we had business, and we had society. Three essentially siloed entities. People doing science say we need fundamental research. Obviously, we do need it. But as a result, sometimes scientists write scientific papers just for the sake of writing scientific papers. Business is doing things that do not really correlate with research, and state is trying to do its best to marry the two fields. It all seems way too complicated. I've been at the head of the institute for a year, and it seems to me that it's not such a tall order. When people communicate, when people collaborate, a lot of problems, even difficult problems related to AI, can be solved rather easily. We have formulated the following equation to try to define practical AGI. It is a sum of two parts. The first one is scientific validity. You come in with an idea, with a project, and you need to prove that it's valid, that it has some scientific value. What is the main criterion of scientific validity or research value, the criterion that shows that it's the best or one of the best solutions in the world? The answer is scientific publications, scientific articles at leading conferences, in leading scientific journals. You can, of course, criticize this criterion, this approach. It has its pros and cons, but that's the best we have at the moment. Which is why so much attention is given to publications from journals, publications with a asterisk, because when you have such publications, you can say with conviction that you are doing something that is of scientific value. And the second part is engineering approach. Engineering approach means there is a direct functional customer. What you're doing needs to be applicable or useful to someone, not necessarily today or tomorrow, But in any case, there should be someone in business or state who understands where this solution can go, how the solution can fit into their processes. I really enjoyed the presentation by Mr. Gasnikov. He is very he's a great academician. He had a lot of formulas in his presentation. I am going to have none. It's not good or bad in and of itself. It's just how it is. Nevertheless, he also mentioned that there should be this ability to find the customer. But it's not unilateral. It's not like science needs to come up with applications, and it's not like business needs to come up with the necessary research. It should be bilateral. But the presence of an end customer does play a huge role in making AI or AGI actually practical. When we're talking about practical AGI, we transition from all kinds of philosophical questions. Is it an intellect? Is it not an intellect? We transition to practical questions. Is it general? Is it different to AIs that are narrowly specialized? For example, there is a domain. You have been working in this domain for 5 years, but you have 0 publications. Well, that is an alarming signal. If you have publications, then at least there is one check. But if these articles are just about an incremental improvement of the previous articles, then still the question remains about the scientific validity, because we all know about the breakneck speed that science is developing, and in the sphere of AI, it's very difficult to build very specific research plans for a long term, because we operate in roughly 2 months horizons in between conferences. There is another big conference going as we speak, with a lot of publications from our team, and in 2 months there will be an ACML conference, and we'll be applying that too with our publications. So 2 months is the biggest horizon. People who say that we know what's going to happen in 3 years and 4 years do not trust their forecasts. Of course, you can build such forecasts, but the value of them is not very evident. There is a mathematical theory, by the way, explaining it. Any extrapolation is unstable, especially if you are at an exponential growth curve. You're trying to make the exponential curve closer to a line, and you always make a mistake. A good example is people criticizing large language models because they are not working properly, because they are not doing something wrong. Well, colleagues, they are just 2 years old. ChatGPT, as we know it, appeared 2 years ago, and in 2 years they made breathtaking progress. Of course, forecasting that they will conquer the world is just as silly, and also saying that they cannot do anything is equally silly. We need to approach them adequately and look at scientific publications and teams who can actually do something of scientific value to solve these problems. And in my presentation, I'm going to show specific examples, specific cases of our institute of AIRI to illustrate my points. Because these are the outcomes that we believe are the main outcomes of our institute that we achieved in a year. You can take a slightly deeper look into the practical AGI and divide it into components. They are pretty straightforward, and if we look at pretty much all available research, you will see that they can be grouped.
However, this categorization helps you to see where there is a lot of talent and some other categories where there is a lack of talent. Data, lack of compute, lack of data, so we can resolve the tasks, the problems that require not more than 8 GPU. If you need more than 8 GPU, then you need additional resources. However, despite the fact that our research institute is working under our organization that has a lot of resources, but we cannot compete with the organizations that use 1,000 GPU. And the people in the Western countries, they can easily build an experiment based on 1,000 GPU. Does it mean that we will lose? No. But that means that we need to change the perspective, to change the methods. That saves time, because having these resources helps, but on the other hand, it kind of makes you lazy. But increasing the compute efficiency is one of the key problems. I'm not going to talk about multimodality, because this is an obvious story. In every specific domain, we can look at the vision language models, the audio processing models that have been published just a couple of days ago. But these can be the modalities that can be related to the data from the MRI scans, X-ray scans, CT scans, or data related to the robot control and monitoring management. So how can you add new modalities in large models? This is another problem, has to be solved, but you can become quite lazy here as well, because you can build a working prototype and then fine-tune this working prototype for the pragmatic prototype. That takes a lot of time. Multi-agency, obviously AI systems are multi-agent. It's great when computer linguistic specialists are saying that as you process texts, I mean, you use text models. The computer linguistic used to use rules, then the language models came into the fore and said that you don't need any rules, and now everyone is writing rules to create agents. So we use the ready-made building blocks to build some structures that would work. Maybe this cycle will return back to the place where we'll have some other situation, but now we have this network of the manual systems, and you might have something that is that looks truthful, but might not be. Embodiment, people say that there is no intelligence if it's not embodied into something. That's a philosophical question, really. And then here we're talking about the robots that perform various tasks and the model of the world. It's not just the statistical patterns that are learned, but trying to predict something, or maybe trying to develop physical laws. This is a picture of some of our employees. We have 29 scientific groups, 3 labs. The number of PhDs and doctors of sciences and candidates of sciences is a little bit lower than the number in other research institutes. But we think that this scientific culture and succession is when the paper that you use to support your status, like PhD, should be pragmatic, should be down to earth, not just some official paper just to get the status. 211 papers were published with A asterisk and A area category. 90 papers accepted. We go to conferences, we make reports, we create international collaborations, and that's fantastic, because one of the most dangerous fields in terms of the regulation is the most democratic one, an open one, which is great. But I've said that 90 papers for 250 people that we have is it's not that much, by the way. So next year we will deliver more papers. This conference, it's for the 3rd time on this conference when I'm going to talk about our medical assistant that was developed together with SperMed AI. This is a showcase when the concept of the pragmatic AGI is working. Now, a year ago, this time, it was decided to create an AGI lab that was tasked with the, well, creation of AGI in healthcare. That was the task. There are people who need that. We have resources for that. There are data, doctors with whom we work. So the task was to compile a solution. Now, there's a lot of systems like that that help patients, that give recommendations. But making a working system that would be better than an average doctor is a hard task. Now, we resolved the problem of the people who Google their symptoms. I think you've done that. In some of the remote regions, it's quite hard to get access to good doctors, and you have to understand whether your condition is critical or you can wait for help. Now, if you go to Sber Health, there will be a medical assistant chat. It's not some chat with some prompts. It's a multi-agent system with good skills. You can try to hack it, in a good way, by asking its difficult questions, and it will for sure give you all the answers that you need. Now, it looks pretty simple. Anyone can ask a question: what to do with my symptoms? What should I do now? And the system that is doing the reasoning, that's a long shot. It's not just some chat that gives you some data. Now, we want to increase the text modality, in the range of modalities, and add videos and images, and this is our plan for the next year for the medical assistant. We also want to have a medical assistant and the moonshot. That's our great foundation model for fluorography. The dataset that we used for training is the training dataset that we gathered together with the government of Moscow. There is no such dataset anywhere in the world, volume-wise. The quality increases dramatically. It's great for me. I love that. You have to explain it, how it works to the doctors, but that's a great solution anyway. We have around 5-6 models like that, and I think we are, but I think we are on the top. I'll now jump through the highlights. Ilya Makarov article was discussing the social and cultural aspect. Language models, a great tool for those who work in the languages, because you can put different prompts and test the hypothesis on various models. How emotions are influencing the economic games. One of the things, or actually psychological or even psychiatric anomaly can be tested. You can make a digital twin and research that. And the work that we've done together with T-Bank, with Kurinkov, Vladislav Kurinkov, you've seen these news, and the largest, a huge data set and the framework that helps you to work to increase your processing time by hundreds of times. And this is kind of a Minecraft. There's a tree of crafts, and based on that, the agent has to train. And it helps the agents to navigate through difficult environments, and it's actually been now used in the field. We can use standard algorithms to go through billions of steps, so testing and developing new algorithms are becoming less and less time costly, and that really helps us to achieve AGI soon. Now, applicable AI vision. In 1 year, you can develop a working product with a number of teams, and everything is Russian-made, the hardware, the computer vision system as well. It is already working. This challenges the idea that scientists cannot work with businesses. In mathematics, you can give just one example to debunk something, and we are debunking it right now. This is a system that sorts waste, and it has been done. We are the good team, the proper resources and good goals, and we had the ready-made solution. transformer in security. Now we try to look inside the model. We try to understand how the brains of the LLMs work. This microscope, looking at it under the microscope, helps to see some unique characteristics that differ, that make models different in terms of the quality, in terms of their trainability, and this is something that we want to expand on further on. If you don't know how to train the model properly and quickly, you can look into it and see why it happens. Now, a couple of words about Aybek Alanov's group. Now, seems like a dumb task to change the hair on high-quality images. First of all, it's very popular, the most popular repository in GitHub. In GitHub, there's quite a lot of groups who are working on these tasks. That's the first thing. Second thing, this is more of an entertainment app, but these same technologies are used in generative design tasks. So you change the material, you move the material from one image to another, you change the style. So you check the technology on this dataset, and then you go to working with data, with synthesis generation, and to other boring stuff, but you have the working technologies. So it's great to have the technologies in advance. And the second story is the image editing. We're working together with Sber devices here. And this paper was published on one of the leading conferences. The task is to change the picture with text prompts. Now in GigaChat you can generate images based on text prompts, but when you say like change the color or change something else, that's a different class of task and prompts, but you can do the same changes with basically zero training, so 0 GPUs will be used. And we plan to use that in the real generative design. We tested based on the images, and it is in demand. Dataset BABILong, Mikhail Burtsov started this project, and we're talking about the fact that LLMs with long context have worse memory. Now, if you want to add a book without retraining a model, and as you added the book, the model can answer new questions and write in a language, but you need to build some benchmarks before you train, and BABILong benchmarks are the ones that are used right now. Creating benchmarks is a very important task for the entire community, by the way, and it's an important step towards AGI. Another benchmark, yeah, we're not only talking about methods, but creation of new benchmarks. It's a dataset for quantum chemistry, was published in new RIPS. This is a dataset that is several times larger than it is used right now. This is the key solution to discover new medications, and for medical chemistry, it can help to replace modeling with neural networks based on the Schrödinger's equation. In the last couple of minutes, I would like to talk about the outlook. Going from the role of the scientist, I'm going to the role of the scientific administrator, manager. You know, sometimes, I mean, I'm still a scientist. I sometimes even write code late in the evening. But my task is to improve the efficiency of the scientific group that I lead and that we were able to gather. People have to understand what is the framework that they work in, what are the limitations, and what is the end result. The AI centers have to develop platforms, that is our goals. But as we were embarking on the way, There was no clear understanding of what a platform is. There was no platforms at all. And when we start to make the final result comply with the requirements when it's already done, that's not the right way to do it, Like, why do you need all these diagrams, all these schemes? But you have to understand that when you divide your efforts in these simple elements, it's easier for you to understand the stakeholders with whom you need to discuss your potential work and other things. And I think we are pretty confidently going towards an AGI creation story, and scientists should not only want to work with theorems, and businesses just want to have a black box that would just have one button. No, we have to work together, and this is how we build the future with artificial general intelligence. Thank you. Thank you very much, Ivan Oseledets. A round of applause. Thank you very much. CEO of AIRI, Ivan Oseledets. Thank you. And a round of applause again.